In this video, I will be discussing the concept of binary eutectic phase diagrams, focusing on the different phase transformations, the reactions that happen, the reaction that the diagram describes, the different phases, and the evolution of microstructure throughout the diagram. So let's start. A binary phase diagram has two different phases, which is liquid and solid phase, and there are three types of lines. The solvus line is the limit of solid solubility. The solvus line happens right here, and the solidus line is a division when only solid is present. So the areas when only solid is present are this one, and this one. So it would be right here. The liquidus line is the division when only liquid is present, and the area where only liquid is present is this top area right here. So this is the liquidus line. Now, this diagram is called binary eutectic because there is an eutectic, what we call the eutectic reaction, and it is happening right here. And if we amplify this, we can see this right here. The eutectic reaction, it is going from liquid to solid 1 to solid 2. In this example of the PBSN phase diagram, here is the eutectic reaction. We started with 61.9% composition of SN, and after the reaction is completed, we have 18.3% of SN and 97.8% of SN. Sorry, 18.3% of SN alpha and 97.8% of beta SN. So now that we have discussed all the different phases and the eutectic reaction, let's focus on the eutectic point. The eutectic point happens at a specific temperature, which in this case is 183. And as I've said previously, the eutectic point divides. The eutectic point happens at the lowest temperature at which pure liquid will exist, and then it goes into two different solids. So now, let's go ahead and see the different microstructures that is happening in this type of diagram. In the binary system diagram, we have a couple of different types of microstructures. In the liquid phase, point A, we have 100% liquid. So this would be the microstructure. As you lower the temperature, it goes from pure liquid to liquid plus solid. So you start getting a little bit of precipitates inside of the liquid. So as you lower the temperature, the more alpha solids you will have inside of this structure. Now, if you were, and this is in this period right here. This is the transformation of the microstructures in the hypoeutectic compositions. Which happen as compositions before the eutectic composition. In this case, it's 61.9. So as you lower the temperature in the hypoeutectic area, you will get alpha solids, precipitates inside of the liquid. At the eutectic point, at the eutectic temperature, you get this eutectic microstructure right here, where you have interlayerings of eutectic alpha and eutectic beta, the two types of solids in this diagram. As you lower the temperature a little bit more, you will get alpha precipitates inside of a structure of eutectic compositions of A, alpha, and beta. This is the transformation in a binary system in the hypoeutectic compositions. But now let's take a look at what happens in the hypereutectic area. So if we were to be at a concentration at, let's say, a 80% composition of SN, and you had A, B, C right here, and D. The microstructure of A is still 100% liquid, so it would be this one. The microstructure of B would be something similar to this one. But instead of proeutectoid alpha, you would have proeutectoid beta. And C, you will still have this eutectoid microstructure right here. And at D, you have something similar to the one that we saw. But instead of proeutectoid alpha, you have little solids of proeutectoid beta. And that happens, and that's the microstructure in the hypereutectoid area. And that is all for an evaluation of the binary system diagram.